Imagine you're trying to write a heartfelt birthday message for your wife, something personal, meaningful, and full of inside jokes. But here's the catch. You're not allowed to share her private history with any centralized AI. And yet you still want the message to be thoughtful, coherent, and beautifully written. This is the core dilemma of modern personalized AI. How do we balance privacy with high-quality, intelligent generation? On one side, centralized large language models have incredible reasoning power, enough to craft nuanced, logical, and stylistically rich content. But they require uploading your private data, raising serious privacy concerns. On the other side, lightweight models running directly on your device can protect your data, because everything stays local. But they lack the reasoning depth to synthesize complex personal context into coherent, high-quality responses. They're fluent but generic, personalized but often illogical. Our pilot study confirmed what many suspected. Even the most advanced local enhancements, like retrieval-augmented generation or parameter-efficient fine-tuning, still fall short. A small model, no matter how well-tuned, cannot match the reasoning quality of a large cloud-based model, even when that large model has no access to your private data. So what if we could combine the best of both worlds? Enter SPECSTEER, a new asymmetric collaborative inference framework that fuses private on-device context with cloud-scale reasoning, without compromising privacy or speed. At its heart, SPECSTEER reimagines collaboration not as a rigid pipeline, but as a Bayesian knowledge fusion process, a way of intelligently blending local intent with global reasoning, step by step. Here is how it works. The system follows a draft verify, recover pipeline. First, drafting. The local specialist, your on-device small model, uses your private history to generate a personalized draft. It's like a first sketch, primed with your unique context. Your wife's favorite restaurant, her love for Italian food, her quirky sense of humor. But here's the key. This draft isn't sent to the cloud in full. Only the generated tokens, the actual words, are transmitted. Next, verification. The cloud-based generalist, your large, powerful LLM, doesn't see your private context. Instead, it performs a ratio-based verification. It compares how likely the draft token is under the generalist's own model, relative to a generic baseline model that doesn't know your private history. This is the genius move. By using a ratio, not an absolute probability, the system filters out hallucinations or strange entities not because they're rare, but because they're surprising in the absence of your private context. For example, if your draft says, let's order from Gino S, the cloud model might assign it a low absolute probability, because it's never seen Gene S before. But when you divide that by the generic model's estimate, the ratio shows it's not an outlier. It's a valid personal reference. Only if the ratio exceeds a threshold does the draft get accepted. If not, the system triggers steering recovery. Here, the cloud doesn't just reject the draft and start over. Instead, it injects a contrastive steering vector, a correction signal, into the logit space. This vector is built from the difference between the private specialist's logits and the generic baseline. Then the local model applies this correction in the context of its own private knowledge and resamples the next token. The result? A corrected continuation that's logically sound and faithful to your intent. No raw data is exposed. No full model states are shared. And yet, the cloud's reasoning power is harnessed to fix the local model's blind spots. This isn't just theory. We tested SPECSTEER across multiple benchmarks, LLM and long-LLM, on a variety of personalized tasks, abstract writing, review generation, topic creation. The results? It consistently outperforms both standalone small models and large cloud models. In one case, a lightweight 0.6B model, even after aggressive local enhancement, scored 23.18 on Rouge 1 for a review task. The cloud model alone hit 31.18. But SPECSTEER, 33.03, a 7% improvement, all while preserving personalization. And the efficiency gains. Even more impressive. While traditional collaborative methods like co-steer or light co-steer apply steering at every token, leading to massive computational overhead, SPECSTEER only acts when needed. It applies correction only when a draft is rejected. This means a 36 times speed up over standard baselines with no loss in quality. In fact, it achieves better quality than continuous fusion methods, while being dramatically faster. Why? Because it avoids unnecessary communication and computation. It's not always on. It's on demand. We also tested its robustness. What if the local model is noisy? What if retrieval fails? What if the private context is imperfect? Even under those conditions, SPECSTEER consistently outperforms the local specialist and remains competitive with the cloud model alone. It acts as a robust logical filter, rejecting flawed drafts, correcting them intelligently, and preserving useful personal signals, even when the input is messy. And it's not tied to one model family. We paired a QN3-0, 6B specialist with a Llama 318B generalist, different architectures, different tokenizers, and still saw consistent gains. The framework is architecture agnostic, thanks to a lightweight byte-level recovery mechanism that avoids vocabulary mismatches. Hyperparameter sensitivity. Stable. For steering strength beta, values between 0.5 and 2 yield consistent gains. Too high. The output becomes disjointed. Too low. It loses personalization. For the verification threshold lambda, we found a sweet spot. Lambda equals 0.1 to 0.5. This gives high acceptance rates, over 80%, while maintaining strong logical guardrails. At lambda equals 0.1, we achieved 36 times speedup with minimal drop in quality. And computationally, SPECSTEER cuts total flops by nearly 5 times in long context scenarios. Why? Because the large model never sees the full private history. The context-heavy drafting happens on the device. The cloud only verifies and corrects when necessary. This isn't just faster, it's more efficient. A true win for real-world deployment. So what does this mean for the future of AI? SPECSTEER isn't just a technical innovation. It's a paradigm shift. It proves that you don't need to choose between privacy and performance. You can have both by building intelligent, asymmetric collaboration into the core of your AI systems. It's not about replacing local models with cloud models. It's about synergizing them, using the local model as a private signal generator, the cloud as a reasoning verifier and recovery engine. And it's not just for personalization. The same principles apply to any scenario where private data must stay local, but high-quality reasoning is essential. Healthcare, finance, legal, education. In short, SPECSTEER turns the edge cloud divide into a collaborative superpower. It's efficient. It's private. It's robust. And it's ready for real-world deployment. The future of personalized AI isn't centralized. It's collaborative. It's intelligent. It's SPECSTEER.